Welcome again to Wickerson Studios. My name is Michael Wickerson, and I am the captain at the helm of the spaceship Exodus. What I have here is a simple algorithm coming off of a video series in 2018 May 2018 by Long Nguyen. Pretty interesting fellow. I've been watching him for a while, watching how he has brought free videos of C in Grasshopper. So this is the video series. If anybody's seen it online, it's the Recordings Workshop live streaming, one of 6. These are long 2-3 hour videos for 6 series, and I'm just going through them, and I'm kind of pinching out the scripts that he's put available online for very simple C programming in the C node in Grasshopper. So what you have here is all this jive that's a little more complex, but specific to dealing in the Rhino. If you're interested and you've been playing in the maths and pulling out the Python node, and you're tired of working in Rhino script syntax dealing with functions, you find yourself more and more importing Rhino geometry, all these different namespaces, and then all this other stuff gets a little funky for me. But it's not something I have to really use. I mean, it's using it itself. But I get down into the meat of it, and I start to read these and understand that, okay, we're pulling things out, pulling out information. We have to build a run script function that's going to be dependent on a curve, that's going to be set at curve, a double that's going to be set at whatever I choose to put in it. And you can see some good examples of this, the divide curve here, pulling out a curve, a float, a tolerance, and segment number. You can see that all these things have to be set in C coding, and I'm not going into details because you've got to put in the time. Anybody serious about this has to be able to spend 400 hours of video tutorial watching at least, in a 3-month period to get a foothold into it. And I just keep going deeper and deeper and deeper, and it keeps circling out like ripples of a pond. Okay, what can I do with it creatively? What can I develop on my own? So I'll start manipulating these in time and getting in here and starting to play with these numbers. Of course, I crash my script when I start working in the C directly. Unlike Python, I've got to save it outside of the running function, stop it, and that's what I'm running into a little bit. But otherwise, it's just if-else statements. It's a very cool idea that you take a curve and generate it. And what it does is it takes the start and finish of that script. So when I import that in here, it basically goes in and finds the start point, the end point, the midpoint of it between here and here. It finds the closest point on curve, then draws that line up, and then recursively does that again and again and again. You can see it calls itself to T-start, T-middle, tolerance. It does it again to divide curve, T-middle, and to end tolerance. You can run that as long as the tolerance isn't met. So I'll let you watch those videos and get into the logic of what's in the script. But once you apply that script, what could you do with it in Grasshopper? So if I grab that and popped it in here and set one curve, you're going to see that I have this ability to go in here and see this curve at high tolerance or low tolerance move away and become a polyline. Now that would be very important for somebody wanting to fluidly draw, make geometries based on a curve or based on something more intuitive, or graph mappers or interpolated curves and NURBS curves. But in time, you're going to want to fabricate this thing. So what will we do after coming up with segments in Grasshopper? So although I'm getting my feet wet in C#, I'm going to have to go a little more into it. The logic behind it's going to help me in Python and Rhino Common, a lot more in the Python node. So I figured, why not? There's all these incredible tutorials on C# and Grasshopper, and there's very hard and few and far between to find Python. Even though Jeremy Graham has done a great job, and others I've found online, I've been through their tutorials, and even Carl Singlein's done it with robotics. I'd apologize for talking fast, but it's just in my nature. So what I have is a bunch of segments coming out of here. First thing I'd want to do to those segments is probably visualize them in a sense of lines and take them to a pipe and take those segments out and put them into a radius, and probably be happy enough with my radius. I may tie it to the geometries before. I'd probably cap it with a 1 or a 2 just to have flat end pipes right here. Actually, that's one way to do it, but I think I'll just go in and hit a quick little tool that gets you not a number slider, but just a number. And the radius is set enough to visualize this, and I kind of like it. What it's like is you can go in here, you can move this around, and it works in a non-planar way as well. So play with that and change it up. Now, what could we do? Also, that geometry, I probably grab the segments, and before doing that, even though I'm happy with that pipe, how could I make it geometrically a little more interesting? This gets you back into your basic Grasshopper visual noting skills. And I think what I'll do is just grab the whole thing and lift up the whole curve. play it up in this direction and see what I can do with it. So I'm going to think of it as segments and go into curves and probably use my utilities and take all those curves and join them to start. So they're coming in as a series of 6 curves, but they're being outputted as 1. Once I get it output as 1, I can just go to starts and finish on those curves. And then from those 2 curves, I can grab myself a little line, and I can pull that from side to side. And now I have a line between it. Not really necessary. I guess I could just mirror it. It'd probably be easier to just do a transformation, grab a quick mirror, and just mirror it to the starter stop point. These segments, that final segment, I could make it to the plane in the start direction, which will put it in one direction, kind of up, mirroring, and you'll see what I'm doing in a minute. Get rid of this line. I'm not going to need it. The plane itself could come from that start. I'm okay with that. I mean, I could do it from the end. It would make a different geometry down there, which is pretty easy. Take that, hold down shift, pop it in there too. Now you've got a little mirrored kind of funky thing that if you're going to start playing with your curves, you can start playing off of it. So kind of fun little mirrored shape. The radius is pretty small, but I'll play up the numbers. So now I've done something with it on the tail end, on the kind of farther along the path, which is fairly interesting. I'll take this all off so I'm not viewing any of that. And then I'd say, well, I have my tolerance that would change how that actually reads. It makes a shape, it makes it smaller, thin. And I never take it down to a really low number or 0, because then I would crash my script. It would just keep going to a 0 tolerance. Let me just take this and edit this up to maybe a 23. And you can see I start to make it a lot more polyline and a lot less steel pieces and pipe that were made. But I also want to play off a little bit parametrically to have different widths of pipe as I kind of estimate and make this thing. And I'm pretty excited about this. I'm going to take it over to a render so we can see what's going on. Maybe just for now, I'll put it in a shaded until I get all my other windows set up. I like to have my zoom extends all. I'll take this one into technical. I'll take this one into pen. And I'll take this one into artistic because I like to do that. It's still pretty small to visualize and see what's going on here. Now, I don't want to be dependent on the curve. I actually want that curve to be off, but it's still referenced in there, and it's been reparameterized, so it works well with the function. I do in the end game is to actually learn more about Python programming and namespaces, so that's why I'm going to continue with this. I'm okay with it capped. Let's take the whole script now. So I'm still playing in Grasshopper after getting some scripts in C, and you customize yourself to all this way of writing and getting scripts that work, but do something with it. Now, once again, a curve, I know what a curve is. I'm going to curve, I'll make an interpolated curve. I know I can feed that in, and I'll do that in a minute. I know it comes from vertices, and vertices are definitely generated from points. So a point system of vertices that comes in, and then I also like to get into my sets and use a wonderful range tool. And I may grab a range tool, and the domain, I'm not going to build another domain. I'm just going to set my domain to something like a 12. I'll be done in a couple of minutes, Beth. Yeah, I'll be fine. Take my range and my X so I can play with that. You can see it up here. It's pretty small, so I'm probably going to want to pull that up into 100 range, and that's going to be comparable to the line of what I'm working on. The Y I'm going to play off of something I like to do very well, and I think a lot of people like doing it as well, graph mappers. Let's throw it in through a graph mapper and slide it into Y and choose something like a graph type sign. Now you could script and code this in the functions and have fun with that and do whatever you want to do. Just hard to grab this little thing, start to undulate this, and I'm going to change my domain up to match it. I'm going to bring it up to 101. I mean, I could be specific and make it exactly 100. That would be fine. And now I can start to get a little undulated shape for a curve, which is pretty fun. And I'm also going to play with that in Z direction. So I'm going to cut and paste that, pull out another graph mapper, probably put that into a Bezier type if I didn't miss my script. Hopefully you're fairly familiar with this and you've played around enough because you're trying to wrap your mind around C so you can learn better Rhino Common, so you can do more outside of Rhino script syntax in Python. That's the main goal here. And once again, I've got another graph mapper that I have to, I copied it, so it should be pretty good. So I've got pretty good parametric control over that. I've got an interesting curve coming out. I can take the whole curve and preview it off, and then I can slide that curve in here, and boom. Now I have a pipe that I can play with. I'm going to have to, I'll take my initial curve and I'll just delete it because I don't need it anymore. And I'll do my zoom extends all to get centered on this. And now you can see I have a pipe that's controllable not only on the size and length of that as I go in here, and I can shorten it if I wanted to or play with that. I can go in here, play with the side and have a little fun and really get some cool shapes. And what's nice is I'm playing with a NURBS curve and a sensibility of that, but in the end I can still fabricate this solely from pipes. And what I'm going to do is also just grab this little kind of function tool of the tolerance, which is kind of interesting because it's an 8. We're playing on different scales. You always have to think kind of theoretically about scale. And there we go. We've got a nice 8 size tolerant. So as we change that, the tolerance is also going to change the shape, but it's also going to do different things to the pipe as I go. So it's a fun little project there. You don't want to go too low, and I think what I'm going to do is edit and bring that up to like 0.1 because I really don't want to crash out this program with a 0. So there we go. We've got something that's kind of playing off of what's happening and not too tricky. The only other thing to do in here is play with different planes, and I could put the plane at that 0 point. I have to wonder what happens if I just grab an XZ plane and plug that in here, and there we go, get another geometry. And once that starts to happen, I just have fun with that. So I'll go to a YZ plane, and I play on the front end and the back end of what I'm doing. And that's kind of centered around a C script. And I think you've got some pretty cool parametric control. You're still focused a lot on Grasshopper and what you can do with it. You've been very playful in that window because that's something that's always excited you about Grasshopper, its ability to do this and visualize and have a visual script node. But still, the iterations are coming from extremely simple scripts. And hell, it's an algorithm that's put together by, let's give him credit. Where'd he go? Up here, Mr. De Castelio algorithm. I don't know what year he made it, but the thing is, I'm going through, I'm going to learn C in the process. I thank Lon Nguyen for putting this all up in line to get people thinking about it. And don't feel bad if you're using a script. I mean, the GitHub's there for a reason. Developers have put their information out. These theorems are not owned except for the person that made it. And I don't know if there's a 50-year policy on what you, the access to those algorithms, but certainly their applications are up for you. So once again, it is research, it is development, and it is the creativity. And I think artists have a role in this just as much as the role of the engineers and architects and certainly programmers. And thinking of a new school of a new Bauhaus, I'm ready to preach and teach it. I know the students have done robotics. I know they've been coding in their high schools. When are they going to apply that into a visual arts school, one of which I'm working at? And I'm very excited to see the outcome of this. And the more and more we go down this rabbit hole, the more and more I can learn from desires and move this into AR and VR and have some fun with this. And I know other people are like, well, what's so great about that? But to me, it's an incredible algorithm that can estimate any curve you want to bring into it and start thinking of fabricating it. I like this because I can then take it and I can bake it. Go down here and bake my pipes in. I can change the caps to, let me just change it quick and you'll see the gaps in these caps. Gaps in these caps. And you can see here where they don't meet up. So obviously you've got a fabrication project of getting correct welds and correct curves. So I probably use the 2 here. And then when I take that in for a bake, I'll probably group at the start. And then with that, I can go in and I can do all the stuff that I used to do in Rhino, which I didn't spend too much time doing. I've learned Rhino from Grasshopper, and I've learned scripting from Grasshopper, so I always come back to that middle ground. And right here, you've got a pretty interesting shape and form that if that's the iteration you want, then pull it aside. If not, let's jump back in. Let's grab another plane shape and turn it around in this direction, which is kind of boring. But I bet if I start playing with my curves, those will come together and do some funky stuff. And they crash at some point, but there you go. I don't know if you're thinking handlebars or roll bars for a Jeep. Mechanically, I'm getting more interested in doing night school classes with other schools and people with different professions. Oh, I didn't know I forgot you could actually adjust it whether that's open. And that's pretty boring what I just did. It made it awfully straight. And I haven't even put a variable pipe on here. Actually, let's go ahead here and change the graph type to parabola and see what happens. Obviously, it's going to pull it up in those directions. So let's do something funky like a Gaussian. That's going to make something interesting that I didn't predict at all. And I can play with the shapes there and change those and have some control because it's pulling in the Z direction. And one other one I just want to try is the sine summation, which is kind of wild little box structured thing that you can play with. And now you're getting into funky geometry and it's really jazzing and grabbing, and the algorithm doesn't know what to do. Of course, I've got to do my zoom extends all to appreciate that. And if I like that one, that's fine. I can bring that one in as another bake. And you should be fairly comfortable. I'm expecting kind of an intermediate level of Python and through the interface before this. Now what I'd want to do is not do a Boolean union. I'd be careful what I select there. Let's pull that aside over here, and then probably then I do my Boolean union on those two. I think I grouped them so they come up together. And just a quick little Boolean union, and there you go. And what's nice about that is if you like what you did, you can jump in here, grab your geometry, let's say one of these, and because they're solid water type form, now you can start playing with the pipes again. So what I'm going to do is just go in here and do a little shell, which doesn't make much sense, but very basic. Grab this one, take off that face, and have a tolerance on it, see if it shells it and opens it up. It did, but it had a lot of problems. And you can see what happened with that. There's a lot of interface and opening it up. So I don't want to be doing that. But all the problems I used to have in Rhino, you can lead back to that and you can really find a crystal clear, perfect, pure mathematical approach through scripting and coding in C and Python. Then do your soft visualizing code in Grasshopper. Honor those scripts and who made them, and end up going into some geometries that possibly start to have some really interesting meaning. Thanks very much for watching. Wickerson Studios.